in this session, we will take up ratio and proportion. The various subtopics that we will be considering here are ratio, their meaning, division of a given number in a ratio. Then we will do some applications. Then we will do some theoretical properties of ratios. Then we will take up mean proportion, and finally we will take variation. Right. So this is the list of topics under this chapter. Okay, now let's see. First of all, what is the meaning of ratio? If I simply say A is equal to 400, B is equal to 300, and the question is find ratio of A and B. What does it mean? First of all, when we say ratio of A and B, it is written as A dot dot B, and it is read as A is to B. So A is to B. So the sign of colon is read as is to. So A is to B. Now what is the meaning of this? Mathematically it means A divided by B. Now see, understand. If there are only two numbers, then we can do this. For more than two numbers, we cannot do this. Alright? Okay, so as of now, we'll just take A divided by B. We can write it as 400 divided by 300. Now, the first thing, ratio always has to be the most simplified whole numbers form. Right? So ratio will always be expressed as most simplified whole number ratio. So this 0, 0 cancel, this 0, 0 cancel. So we have 4 by 3. Then we write this as 4 is to 3. This is the basic meaning of ratio. Alright. Suppose we don't want to write it like this, no problem. We could have also done it like this. A is to B is equal to 400 is to 300. So just keep them in a line and then cancel out the common factors. So here the common factor is 100. So 100 gets cancelled. Finally the answer is 4 is to 3. Alright. This is the basic meaning of ratio. Let's take another example. If we say A is 320, B is 560. Find the ratio of A and B. So we write A is to B as 320 is to 560. Then 10 gets cancelled out, so 0, 0 cancelled out. Then we can divide by 4, so 4 8s are, or we can divide by 8 also, so 8 4s are and 8 7s are. So the final answer is 4 is to 7. So what you have to do is, we have to cancel out all the common factors. Okay. And in the end, whatever the most simplified form, 4 is to 7. Now there is nothing common. We can also call them co-prime numbers. So once we achieve co-prime numbers, we leave them there. Alright, let's take some more examples. A is equal to 480. B is equal to 144. C is equal to 1680. Find A is to B is to C. So we simply write it equal to 480 is to 144 is to 1680. Right? Then cancel all the common factors if there are any. So for example, 10 is common to these two but not in this one, so we cannot cancel it. Alright? I think the simplest that you can start with is 4. So if you divide 480 by 4, you will get 120. Then 144 by 4, you will get 36. 1680 by 4, you will get 420. Further we can divide by 4, so we get, or I like one more step. So after division by 4, so when we are dividing by 4, we have to divide each one of them by 4. So it is 120 is to 36 is to 420. Still we can divide by, let's say, 4. So if you divide by 4, you will get 30 here, you will get 9 here, and you will get 105 here. Now, this is an odd number, this is an odd number. Now we can divide by 3. So if you divide by 3, you get 10 here, you get 3 here, you get 35 here. Now even though there is a common factor in these two, you can't do anything about it because there is no common factor in all the three. Alright. So once you get this situation when there is no common factor in the given numbers, then we say that this is the final ratio. So ratio of ABC given here is 10:3:35. How do we read it? If we read it as 10:3:35. This is how we read this. This is not important, but just for the sake of clarity, I am saying that this has to be read as 10:3:35. Alright, let's take some more situations. So if the numbers are given, you can just divide by the common factor. Go on dividing till the time there is a possibility of division, or till the time there is any common factor other than 1. Okay, let's take another one. Now here we have taken all integers till now, or whole numbers. Let's take some fractions. If I say A is equal to 0.276 and B is equal to, let's say, 13.8, find A is to B. What will be this one? Now see, 0.276 is to 13.8. Now these are fractions. So first you simplify these. So this is 276 upon 1000 is to 138 upon 10. Right? Now the way we could divide, similarly we could multiply also. Okay, so what you should do is you multiply by 1000 on each side. So you get 276 is to 138. Now if you multiply by 1000 here, this 1000 gets cancelled. And if you multiply by 1000 in this one 0 will get cancelled and 2 zeros will come. You can easily see that 138 twice is 276. So this whole thing is going to be cancelled by 138. So if you cancel it by 138 or divide by 138, you get 2 here and 100 here. Now this 2 divides 100, so we get 1:50. So the answer of this question, which asks ratio of A and B, is 1:50. So what did we do? We repeat. These were decimals. So first we converted into simple ratios, right? Simple fractions. Then we had to remove the denominator. So what did we do? We multiplied by 1000 in both these items. So if you multiply this one by 1000, 276 by 1000, multiplied by 1000, you get only 276. Multiply this 138 by 10 by 1000, 138 by 10, we multiply by 1000, 10 gets cancelled and we get 13800. Then this whole thing is divided by 138. So 138 into 2 is 276. Alright. So 138, this because 138 is very prominently visible here, and this is twice of 138, so this becomes 2, this becomes 100. Then further this is divisible by 2, both are divisible by 2, so you divide by 2, you get 1:50. So the final answer of this ratio is 1:50. Alright. Let's take one more example. If I have A is equal to 21 by 40 and B is equal to 16 by 35, what is the ratio of A is to B? So A is to B will be 21 by 40 is to 16 by 35. Now here it is 40, here it is 35. Alright. So what you should do is you multiply by 40 to both of them and you also multiply by 35 to both of them. So what do we get? If you multiply this by 40, 40 gets cancelled and multiply by 35. You can, in other way, you can also say that you can cross multiply. You can directly cross multiply. This is same as saying 21 by 40 whole divide by 16 by 35. This is same as saying this. So 21 by 40 into 35 by 16. So this can be written as 21 into 35 is to 40 into 16. And if there is any common factor, cancel them out. Okay. So we can simplify, we can cancel by 5, so 7 times, 5, 8 times. I don't think there is anything else further that is possible. So 21 into 7 is 147 and 8 into 16 is 128. So the final ratio of these three quantities is 147 is to 128. Alright, let's take another one. If I say that A is equal to 25 by 6 and B is equal to 15 by 16. Okay, what is A is to B? This is 25 by 6 is to 15 by 16. There is another way to look at it. One way, as we did there, you take 16 here and 6 here, or you can directly cancel out, whatever way you feel comfortable yourself. So if I directly cancel out, so 5 times, 5 3 times. Now these two, both these two are in denominators, we can cancel them again. So 2 3 times, 2 8 times. Now this 8 goes on this side, 3 goes on this side. So we have 5 into 8 is to 3 into 3. So this becomes 40 is to 9. This is the final answer. Let's take 3 quantities, then it will make a little more sense. If we have A is equal to 0.2, B is equal to 0.36, C is equal to 4.2. Now find the ratio of A, B, C. Now A is to B is to C will be 0.2 is to 0.36 is to 4.2. Now listen very carefully. One thing is that you can do is write this as fraction 2 by 10, 36 by 100, 42 by 10, and then you multiply by the common LCM. Always do that only. So 2 by 10 is to 36 by 100 is to 42 by 10. Now what should we multiply by? Here it is 10, 100, 10 multiplied by 100. So all of them will become simple. So if you multiply this by 100, you will get 20. If you multiply this by 100, you will get 36, and this will become 420. And then further simplify if it is possible. I think it will be, all of them are divisible by 4, so we divide by 4, you get 5 is to 9 is to 105. So even though there is a common factor in these two, you can't do anything about it. There is a common factor in these two, you can't do anything about it. Remember, the combined ratio of all the three, this is the last most simplified form. So ratio is 5 to 9 is to 105. Alright. So if the numbers are given, if the values are given, what you do is you simplify them and write them together with a sign of colon or 2 dots, 2 vertical dots, 2 dots in a vertical column, and cancel out any common factor if there is any. Let's take some situations like this. Question can be, I'll put the heading as divisions. Question is, divide rupees 7,200 among 2 people A and B in the ratio, let's take 2 situations, 4 is to 5, and do the same question again with a different ratio, 2 is to 3. Okay, now first do it for 4 is to 5. How do we go about it? The first one. Now there are 2 ways of doing this question. One, see, if the numbers were given, you could find the ratio by dividing. But if the ratios are given, we can't say anything about the values of the numbers. Alright, remember, after cancelling out some common factors, we would have got the ratio as 4 is to 5. So here we have A is to B equal to 4 is to 5. We don't know what did we cancel out. Now, something that we don't know in mathematics, we can take leverage and we can assume some variables. Suppose we cancelled out X. That means A could be we could take A as 4x and we could take B as 5x. Remember, whatever we cancelled out, let's assume that number was X. Then multiply X to both, so they will become independent. Now we have total amount of 7,200, so that means 7,200 is equal to A plus B. Now put 4x and 5x there, so 7,200 is equal to 4x plus 5x. So 7,200 is equal to 9x. So we get x is equal to 7,200 by 9, that is 800. Now once we get the value of x, we can find both A and B. So A will become 4 into 800, that is 3,200 rupees. And this will become 5 into 800, that is 4,000 rupees. So this is how we can divide. I'll take this a little while later. This is one way of doing this. Now, we don't need to actually write all these things. We can do this directly also. Let's see. Let's look at the ratio thing again. The ratio gives us a relation. So here the relation between A and B is 4 is to 5. Let's read this ratio again and try to understand in a different perspective. This means if A gets 4 rupees, B must get 5 rupees. Alright? If suppose A gets 4 ka double, that is 8 rupees, then B must get 10 rupees. Suppose B gets 50 rupees, then A must have got 40 rupees. Right? So numerically they are related, or they are related by unitary method, you can say. Okay. Let's come back. Let's consider the given numbers 4 and 5. The very simple fundamental meaning would be, if A gets 4 rupees, B should get 5 rupees. So what would be the total sum of their amounts? That will be 4 plus 5, which is 9 rupees. Now, I'll read that statement. Out of every 9 rupees, A is getting 4 rupees. So in terms of fraction, how do we present the share of A? The share of A can be presented as 4 out of 9 parts. So what we are saying here, that divide the whole thing or whole amount in 9 parts, give 4 parts to A. So the share of A in terms of fraction can be written as 4 divided by the sum of 4 and 5, that is 9, multiplied by the total value, that is 7200. So directly you can get this value, which is 800 into 4, 3200 rupees, 3200. Right? The share of B, this will be out of 9 parts, B should get 5 parts. So that in terms of fraction, we can write it as 5 by 9 fraction of the total amount. So again, 800 into 5, which is 4000 rupees. So if you look at this closely, it's exactly the same procedure. It's just that here we are using X as a variable, here we are not using any variable. Alright. In a bigger question, obviously, this will be a small part. So we can do this very fast like this. In some cases, this X has to be used. We'll see. We'll look at those questions also. Okay. Now let's take the second part. If the ratio was 2:3. So we say that A is to B is 2:3. Total amount is given 7200. So share of A, now we'll do it directly. Share of A will be, if we divide the whole thing, in how many parts do we need to divide the 7200? 2 plus 3, that is 5 parts. So out of every 5 parts, A should get 2 parts. So the fractional share of A will be 2 by 5 into 7200. Divide it carefully. 1440 into 2, so it is rupees 2880. Similarly, share of B, either you subtract this 2880 from 7200, or you can calculate like this, 3 by 5 into 7200, which is, if you divide this by 5, it gets cancelled, 1440 into 3. So 42, 43, 20 rupees. Alright, so these are different ways of divisions. So in some cases, we will use this fraction thing. In some cases, more complicated situations, we make them independent. And to make them independent only, we need variables. Let's take another question. Divide rupees 4800 among A, B and C in the ratio 3:5:7. Alright, very simple situation. So what we are given with is A is to B is to C, that is equal to 3:5:7. So let's take share of A, that will be equal to, how many parts do we need to divide the whole given thing? 3 plus 5 plus 7, that is 15 parts. So out of every 15 parts, A should get 3 parts. So that is, in terms of fraction, it is 3 by 15 into 4800. Simplify a little bit. So if you divide this, you will get 15, 320. So 320 into 3, which is 960. I'm considering rupees because most of the questions we'll get for would be for division of amounts, the money. Now B would be 5 divided by 15, or you could have also done 5 times 15 and then you could have cancelled. You get the same answer. Now 5 by 15 into 4800. Now that we have already done this once, so no need to do any new calculation, continue with that. So 5 into 320, that is 1600 rupees. Then C share would be 7 by 15 into 4800. Still the same thing because we have already done this calculation once. Now 7 into 320, that will be 2240 rupees. You can always go back and check. The total of these three should be 4800. Let's check. Now 60 and 40 is 100. Now 960 and this is 1000, 2600, 4800. Right? So this total is 4800 rupees. Third one. If we have divide 3.75 among A and B in the ratio 13:17. So it doesn't matter how small or big is the number, we just follow the procedure. A would be. So now by now you know that the total number of parts will be the sum of these things. So A share will be 13 divided by 13 plus 17 is 30. So 13 by 30 into 3.75. You just do the multiplication, division, whatever is required. Okay, what you can do is 3.75 by, this can be written as 375 by 100. So it is 13 by 30 into 375 by 100. Now 3 10 times, 3 125 times. Do not touch these 10 and 100 because they will convert into decimal. Now 13 into 125, this will become 1625 upon 10 and 100, which is 1000. So the final answer is 1.625. And here what you can do, the second part would be 17 divided by 30 into 3.75, or you can subtract this number from this to get your final answer. Right? So 17 by 30 into 3.75, which is 17 by 30 into 375 by 100. So this 3 10 times, 3 125 times. So 17 into 125 is multiplied by 1000. So it is 2.125. If you just check by adding these two, you should get 3.75. An amount is divided among A, B and C in the ratio 5:7:15 if the difference between the amounts of B and C is rupees 1,200. Find total amount and their shares or their individual shares. So the difference between the amounts of B and C is 1200. Now, one safe way would be to introduce x and solve it. So I would say A is equal to 5x, B is equal to 7x, C is equal to 15x. Here we don't know the total amount. We have to find the total amount. So we assume this. Then we say the difference between B and C. Right? So the difference between B and C, obviously C is higher. We can see the difference between B and C is 15x minus 7x. That is 8x. This 8x is given equal to C minus B. That is 8x. That is equal to 1200. Don't worry about the order much as of now because the question simply says the difference. So we take the difference between C and B, whichever is higher. Now 1200. Now 8x equal to 1200. So x is equal to 1200 by 8, which is 150. So we get the value of x. We can find the individual amounts from here. This will be equal to 5 into 150, 750 rupees. Similarly, this will become 7 into 150, 1050 rupees. Similarly, C would be 15 into 150, 2250 rupees. If you want to find the total amount directly, add all of these. Now this will become 5 and 7, 12 and 15, 27. So the total amount can be equal to either by adding all these three or adding all these three. So 27x, that is 27 into 150, which is equal to 4050. If you add these three, you should get the same answer. So rupees 4050 is the total amount. Rupees 7500 are divided among A and B such that 1/3 of A is equal to 1/5 of B. Find the shares. Nothing to worry, just a simple word problem, nothing else, nothing more than that. Okay. Now 7500 is divided among A and B in the ratio in such a way that 1/3 of A. So we simply write A by 3, that is 1/3 of A, is equal to 1/5 of B, so B divided by 5. Now see, from here we get A by B equal to 3 by 5. And from the definition of ratio, it is nothing but ratio of A and B, which is 3:5. That's it. So effectively we get the ratio of A and B, and then we can do the division. Share of A would be equal to 3 by 8 into 7500. simplify as much as possible. So 4 2s are 1875. Okay, so simplify, you get A equal to 3 into 1875 by 2. So this is 5625 divided by 2. So we have 2812.5 rupees or 2812 rupees and 50 paise. B will be equal to 5 by 8 into 7500. This is 2 times, this is 1875 times, 1875 into 5, 9000 and 375. So 9375 by 2. So it is 4687.5 rupees. If you add, you must get the same value, 7500. Alright? So the question presentation can be in different manners. So here there was a word problem that was given like this, that some fraction of one part is equal to another fraction of the other part. If twice of A is equal to 5 times B and their difference is 480, find A and B, or 480 rupees, find total amount and their shares. So it's very clearly says twice of A. So 2A is equal to 5B. So what do we get? We get simple ratio of A and B. So B comes on this side, 2 goes on the other side. So it becomes 5 by 2. So what do we have? A is to B is equal to 5 is to 2. Right? Then the difference is 480. Now see, the way we said addition, similarly we can do a subtraction also here. It's like if A gets 5 parts, B gets 2 parts. So the difference will be 3 parts. 3 parts out of the total 7 parts. So we can simply say that 3 by 7 into the total. Now this is another way to do some of the questions. See, once again, if I divide the whole thing in such a manner that A gets 5 parts, B gets 2 parts, so total 7 parts. That means that the difference would be 5 minus 2, that is 3 parts. So the difference can be written as 3 by 7 into total, and that is given equal to 480 rupees. So from here we can simply find total value. So total is equal to 480 into 7 by 3. Simple unitary method application. So 160 into 7, that is 1120. Look at this closely. You can also take x. If you take x, then the other way could be, we have A is to B equal to 5 is to 2. So I'm just giving you the other method. That other method could be like this, that A taken as 5x, B taken as 2x, and then we say 5x minus 2x, that is the difference, is equal to 480. The answer is going to be the same. So 3x is equal to 480. So x is equal to 160. I wouldn't say which method is better. It is about, because the time taken, I believe, because of the numbers involved, it is going to be the same. Right? Numbers are simple, so the time taken is going to be the same. Now x is 160, the total amount will be equal to, from here 5x plus 2x, that is 7x, 7 into 160, which is 1120 rupees. So these are the total amounts. Now once we get the factor, that is 160 was one part, or x is one part, or x is 160, 160 is one part, then we can find the individual shares. A would be equal to either from here or from here. After this it is going to be the same. So it is 5 into 160, which is 800, and B share would be 2 into 160, which is 320 rupees. So whichever way you feel comfortable with, you should use it. So using X is like, using a big weapon. So whenever necessary, you're not able to understand things, you do with the help of X. Otherwise, some cases you can do with shorter methods also. Okay. So all these questions were based on division into given ratio, division of a given amount into a given ratio. Now the applications will be huge. Ratio is one of the most important tools. Alright. So let's take this. So what I'll do, I'll take one example from every topic, okay, and then we'll follow. First is average. I'll take a similar example. The average marks of class 1 is 60 in a particular exam, and of class 2 is 75. If ratio of number of students in these classes is 3:2, find the combined average marks of these two classes together. So here another concept of average will be used. How would you calculate average? The total sum of marks divided by total number of students will give you the average. Alright. Now we don't know the number of students. Average of class 1 is 60. See, how was that 60 calculated? The 60 must have been equal to the sum of marks in the class 1 divided by the number of students in class 1. Okay, this must have been the way to calculate 60, right? But we don't need to get into this detail, right? Here, the number of students ratio, similarly, the 75 must have been calculated like sum of second class divided by the number of students in the second class. This must have been the way. So, as you can see, the overall combined average combined should be equal to the total sum, that is sum of class 1 plus sum of class 2, divided by total number of students in class 1 plus total number of students in class 2. But we don't know the numbers. Okay. But there is another that you can see from here. Sum of first class will be equal to 60 into number of students in the first class. That can be put here. So I would put it like this: 60 into number of students in the first class plus 75 into the number of students in the second class divided by number of students in the first class plus number of students in the second class. Alright. Now this looks pretty big. Okay. Whereas this does not require writing all these things. What we could do, if the ratio is given, ratio of number of students is given is 3:2. So let's assume that the number of students in these two classes are 3x and 2x. And then do the calculation directly. And the most interesting part, instead of taking 3x and 2x, you can simply take 3 and 2. So that is the beauty of ratio. You don't need to take 3x and 2x. Suppose, what happens if you take, let's say average combined is A. If you take number of students as 3x and 2x, then what will happen? This expression will become directly 60 into 3x plus 75 into 2x divided by 3x plus 2x. Can you see that x will come common from numerator, x will come common from denominator, and it will get cancelled out. Right? So it was not required to be taken as 3x and 2x. So what I'm trying to say here is, you simply find, so instead of writing all these things, what you would do, you will straight away start like this. A is equal to, that is the final average, combined average, is equal to the sum of marks in the first class. How would you find the sum of marks in the first class? The average of first class is 60. Average, that means average per student, that is 60. Into the number of students, let's assume from the ratio that the number of students is 3. Plus, now if you have assumed the number of students should be 3 in the first class, then in the second class it has to be 2. So second class average is 75 and number of students is 2. And in the denominator you just take total number of students as 3 plus 2. That's it. This is the only thing that you were supposed to do in this question. So average will be equal to 60 into 3, that is 180, plus 75 into 2 is 150, divided by 5. So it is 330 divided by 5, and that is 66. This is the combined average marks of these two classes. When we do average chapter, we will study this formula in a greater detail, right? just for reference, I'll write it. This is called weighted average is equal to this 60 and 75 called the value. So V1 into 3 is the weightage W1 plus 75 is V2 into W2 divided by total weightage W1 plus W2. So we'll study this formula again, but as of now, I just wanted to show that ratio, the number of students presented as ratio, the numbers involved in the ratio can be directly taken as the actual numbers. Alright. So this was one application. Now let's take another application, mixtures. One very interesting topic of mixtures. Let's take a question like this. The ratio of milk and water in a mixture is 3:2. When we add 60 liter water, the ratio of milk and water becomes 9:7. Find original volume of mixture. How will you do this question? Now there will be many methods, at least 3 ways to do this question. We'll take each of those ways one by one. First we'll take the conventional route. So I'll say initial situation, milk is to water ratio, that is 3:2. Let's assume that milk is 3x liters, let's say, and water is 2x liter. Liter is just a unit, the variable is x. Alright. In the final situation, the ratio of milk and water is given 9:7. Now generally what people do is we take this, they take this as 9x and 7. No, we can't do that. Right? Because there is a relation also. And the relation is from this situation to this situation we have added 60 liter water. Okay? So hold on. In the final situation, what will be the milk quantity? Whatever was the milk quantity in the beginning. For one moment, leave this. Okay? In the final situation, the quantity of milk will remain 3x liters. And the quantity of water will become 2x plus 60 liters. Just look at this carefully. Whatever was the quantity of milk in the initial situation will remain same in the final situation. Whatever is the quantity of water in the initial situation, 60 liter will be added to that. So what is the total quantity of milk finally? 3x. The total quantity of water finally? 2x plus 60. So the ratio will be 3x upon 2x plus 60. This is the ratio of milk and water. And this is given as 9/7. Okay, so if you solve this, you will get the value of x. So 7 here and this 2x plus 60 on this side. Cross multiplication, you get 21x is equal to 18x plus 540. So we have 3x is equal to 540, x is equal to 180. Don't forget, this x is not the answer. What was the question? The question was find the original volume of mixture. Now original volume of mixture will be the total of these two. So I'll put it here, original volume will be equal to 3x plus 2x, that is 5x, hence it is 5 into 180, that is 900 liters. So this is one safe, simple, conventional method. Okay, now let's take another one. The second method, I'll do the whole question again from the beginning. Second method is based on the process of division that we had done initially. Okay, so this is method 1. Now we are doing method 2. Look at this very carefully. Here also we assume a variable. Let's say initial volume is V. So here it was two-step process. First we calculated X, then we calculated volume. Here we are assuming the volume to be V. V liter. So final, what will be the final volume? The final volume will be, what are we doing? We are adding 60 liter water, so final volume will be V plus 60 liters. Now here, what is the ratio of milk and water? It is 3:2. And what is the ratio of milk and water in this case? It is 9:7. Right? So we have changed the variable, but the logic still is the same. And what is the basic logic here? It was the milk quantity is still going to be the same. Right? So here also milk quantity is going to be the same. We have done the method of divisions. Now divide V liter in the ratio 3:5. And no need to find both the fractions, just find the part of milk. The part of milk will be, the ratio is 3:2, so it will be 3/5 into the total quantity, that is V. Similarly, here milk quantity will be 9:7, so 9/16 into V plus 16. Okay, and the quantity of milk is going to be the same, so equate them. Understand that we are adding only water. There will be no change in the quantity of milk. So find the quantity of milk in the initial situation, find the quantity of milk in the final situation from the ratio division method. So ratio is 3:2. So the fraction of milk will be 3/5 into the total, that is V in this case. Here the ratio is 9:7. So the fraction of milk will be 9/16, 9 plus 7, 16, multiplied by the volume at that time, that is V plus 16. Now cross multiply and simplify. So 16 comes to this side, so 16 into 3, that is 48V. And 5 goes to this 9 side, that is 45 into V plus 16. So here we can in fact divide by 3, so it becomes 16 and this becomes 15. So we have 16V is equal to 15V plus 15 into 60, that is 900. Oh, so V is equal to 900 liters. So this is method 2. We will take method 3. Let's see. What is the initial situation? Initial milk is to water is 3:2. Final milk is to water is 9:7. Okay. Now whatever method we do here is also going to lead us to one of the next topics. Okay. Now see, we know that only water has been added. The milk quantity should remain same. But here in the initial situation, the number corresponding to M or milk is 3. In the final situation, number corresponding to milk is 9. They are not same. Let's make them same. We know how to cancel out and how to multiply, right? So if you have to make same, what do we have to do? We have to take LCM of these two numbers. Remember, we have to take LCM of these two numbers. In this case, incidentally, this is already a multiple of 3. This 9 is a multiple of 3. So we just need to multiply this by 3. So if you multiply this by 3, this will become 9:6. This will remain same, 9:7. Now here, the numbers corresponding to milk have become same. That's what we wanted. At that time, in that situation, look at the quantities of water, 6 and 7. So how much has been added? According to these numbers, 1 has to be added. Listen very carefully. Once we have made the number corresponding to milk same, then we compare water. So here water is 6 liter and milk is, water in this case is 7 liter. That means water added is 1 liter. But we know that the water added is not 1 liter. How much is it? It is 60 liter. And which quantity do we have to relate this to? We have to relate this value to the original volume. Now here, come back. The added value is added to the original volume, that is 9 plus 6, which is 15 liter. So just apply unitary method. So we can say 1 liter water is added to which volume? See, understand, 1 liter is added when the volume is this one, that is 15. So 15 liter volume. Okay. So if we have added 60 liter water, what will be the volume? So we know the unitary method, that will become 15 into 60 by 1, which is 900 liters. Or even we don't need to do this, 1 liter for 15, so 60 liter for 15 into 60, that is 900 liters. I'll repeat once more. The logic here is the quantity of milk should remain same. Okay. So we make the number corresponding to milk same, and then we compare the quantities of water. So this becomes volume equal to 900 liters. So these are 3 different ways of doing this question. Okay. Now the third application would be the problems on ages. I simply put the question as ratio of ages of A and B 12 years ago was 4:7 and 8 years from now the ratio will be, so ratio of ages of A and B in the same order will be 3:4. Find the present ages. Alright, so here again we'll have many methods as we did for mixture question. It's more or less same as that question. Okay, we'll just take situations like this. I'll say present. This is what we have to find. Then we have 12 years ago. Then we have 8 years later. Okay, so this is the situation given. Right? Now 12 years ago, the ratio of A and B, ages of A and B was 4:7, and 8 years later, the ratio of ages of A and B is given 3:4. We can start from any situation. You see, we can introduce a variable x here. So age of A can become 4x years and age of B can become 7x years. That means the present ages would be, let's see, this was 12 years ago. So now the ages would be 4x plus 12. So 4x plus 12 and 7x plus 12. So this is what we have to find. Alright. Then further 8 years, next 8 years, after 8 years what will happen? This age further will increase by 8. So age of A should become 4x plus 12 plus 8. So that is 4x plus 20. And age of B should become 7x plus 12 plus 8. That is 7x plus 20. Or you can see directly from here to here there is a total gap of 20 years. There is a total gap of 20 years. Okay, so 4x plus 20, 7x plus 20. So these are the ages of A and B 8 years later. And there the ratio given is 3:4. So we can simply use this 4x plus 20 upon 7x plus 20, and that ratio is equal to 3/4. Cross multiply, so 16x plus 80 is equal to 21x plus 60. 16x goes to the other side, so we get 5x. This side we get 20, so x is equal to 4. Once we get the values of x, we put them here, we find their ages. So age of A here will be 4x plus 12. So 4 into 4, 16 plus 12, that is 28 years. And 7x plus 12, that is 28 plus 12, 40 years. Okay. So this is one way of doing this question, wherein we have started with this. What we could have also done, we could have started from here and subtracted. So I'll take that one also. If now this is a different method. Suppose we started from this situation 8 years later, and we put a variable as A is to B 3:4, and we say A is equal to 3y and B is equal to 4y. So if you come back to the present situation, age of A, that is present situation, age of A would be 3y minus 8 and age of B would be 4y minus 8. If you further go backwards, 12 years ago, in that case, age of A will become this minus 12, so it will become 3y minus 20. Or this will become 4y minus 20. Or you could have seen directly this was 20 years back. Okay. This difference is net difference between these two situations is still 20 years. Alright. Now ratio of these two quantities given was 4:7. So we can simplify 3y minus 20 upon 4y minus 20 equal to 4/7. Solve this and put the values of y here, you will get the same answer. So this comes out to be 7 into 3, 21y minus 140 is equal to 16y minus 80. So 5y is equal to 60. This 140 goes to the other side, y is equal to 12. So put the values of y in this, you get A as 12 3s are 36 minus 8, that is 28 years. And B as 12 4s are 48 minus 8, that is 40. The answer should be the same. Now, there is one more way without any variable. So if you just try a little bit, you can understand that method also. I'll explain it. See, ratio gives us a lot of freedom, right, to use numbers, tables, and many other things. Again, I'll start like this. Present, 12 years ago. In the exam, you will not use multiple methods. In the exam, you have to use only one method, right? Whichever comes to your mind first. Okay. Okay. Now, 12 years ago, the ratio was given as, look at this very carefully, 4 and 7. What we are doing is we are assuming that these are the ages. So, let's assume that age of A 12 years ago was 4 years and age of B was 7 years. Okay. Now, what is the difference between 4 and 7? If I assume this 4 and 7 to be original numbers, here the difference is 3 years. Now, ages are something very interesting. The difference of ages of any two people or any two persons will always be constant. You know, for example, if your younger brother or elder sister, if let's say there is a difference of 2 years in your and your sibling's age, that difference will always remain 2 years. However, angry you get on that fact, that cannot change. So if somebody is elder to you by 2 years, for your entire life will that person be elder to you 2 years, by 2 years, or and vice versa and so on. Okay. So here the difference of ages is 3 years. So at any point in time, the difference of their ages should be 3 years. Now why am I saying this? In this situation, 8 years later, the ratio of A and B is given as 3 and 4. So can we take this 3 and 4 as the original ages? No. Because if we take them to the original ages, the difference becomes 1. How is that possible? How is it possible that when the time goes ahead, the ages reduce? That is not possible. Now here, the difference of 3 and 4 is 1. As we did in some of the earlier question, make it 3. How will you make 1 equal to 3? Multiply by 3. So if you multiply by 3, this 1 becomes 3. Now you cannot multiply just this 1 by 3. So to get this 1, what did you do? You subtracted this from this. So you have to multiply by 3, so multiply this whole thing by 3. So A will become 9 years and B will become 12 years. And hence the difference will become 3 years. Now these values can be taken as the original values. Okay. And what it means is now these values are in tandem with each other. Now they are in coherence. They can be considered together. Here the difference is 3 years, so here also the difference is 3 years. Fine. So one thing we have established, the difference of age is 3 years, so they are also 3 years. Okay. Now look at their individual ages. What is the age of A here? 4 years. What is the age of B here? A here in this case, that is 9 years. So how much is the gap? How much is the time duration? That is 5 years. Is this 5 year correct? No. What is the total gap between these two situations? Between these two situations, the total gap is 20 years. That means the age of both A and B should have increased by 20 years, but whereas in this data, the age of A has increased only by 5 years. So make this 20. Now to make this 20, what will you have to do? Multiply by 4. So if you multiply by 4, these two values will become 16 and 28. These two values will become 36 and 48. And these are the actual numbers. So ages 12 years ago, 16 and 28. Hence you can find the present ages by adding 12. So 16 plus 12, 28 years. And 28 plus 12, 40 years. Or from here you can subtract 8 to get the present ages. So 36 minus 8, that is 28 years. 48 minus 8, that is 40 years. Alright, so this was one very interesting question. So you don't worry about the difficulty thing. You just try a couple of more times. What I have done, I'll just explain it once more. We assume these 4 and 7 to be the original values. The difference was 3. Now you may also ask, why can't we start from here and this divide by 3? Then the process will become a little cumbersome. That is why, to keep the things integers, we took this as the, because the difference was 3 here, the difference was higher here, so we took this as the original value. So 4 and 7 original value. Corresponding to this 3 and 4, difference is 1. Make it 3 by multiplication of 3. So this 3 becomes 9, 4 becomes 12. Now the difference is 3 years, here also difference is 3 years. So now all these 4 values can be taken together. In that case, the age of A has gone from 4 years to 9 years. That means it has increased by 5 years. Whereas it should have increased by 20 years. So make this 5 20 by multiplication of 4. So multiply each of these numbers by 4. So you get the ages 12 years ago, you get the ages 8 years later. From any one set, you can get the present ages. So the answers would be 28 years and 40 years. Fourth question, fourth application. In a bag, there are coins of 1 rupee, 50 paisa and 25 paisa. The ratio of number of coins is 5:6:8. If the total amount of money in the bag is 120 rupees, find the number of coins of each denomination. Okay, try this one. So I write denomination here. The denominations are, denomination means here the value per coin. That is 1 rupee, 50 paisa, that is 1.5 rupees and 25 paisa. Then number of coins. Number of coins is 5:6:8. Now what I will do, I will not take the variables. I'll just assume that 5, 6 and 8 are original number of coins. So net value. Now what do I mean by saying net value? So I'm assuming that there are 5 coins of 1 rupee. So the net value will be 5 rupees. 50 paisa, there are, let's say, 6 coins. So the net value will be 3 rupees. 25 paisa, there are 8 coins. So the value will be 2 rupees. So the total amount of money should be 5 plus 3 plus 2, that is 10 rupees. 10 rupees for how many coins? We have assumed this to be the original number of coins. So let's take them. So 5 plus 6, 11 plus 8, 19 coins total. Right? Or 5 coins of 1 rupee, or 6 coins of 50 paisa, or 8 coins of 25 paisa. Whichever you want to find. Look at this again. What did we do? We took this 5, 6 and 8 as the original number of coins. Then the values will become 5 coins into 1 rupee, so 5 rupees. 6 coins into 50 paisa, so 300 paisa, that is 3 rupees. 8 coins into 25 paisa, that is 200 paisa, that is 2 rupees. So the money, net value will be 5 rupees, 3 rupees, 2 rupees. So total amount 10 rupees. So in a total value of 10 rupees, this type of situation, the total number of coins should be 19. Or 1 rupee coin should be 5. Or 50 paisa coin should be 6 in number. And 25 paisa should be 8 in number. In the question in the exam, only one of them would be asked. I am just explaining how to get all of them. Okay. Now, what is the information given? The total money is 120. So, unitary method, using unitary method, if this 10 becomes 120, how much will each one of them become? I think it's very easy to calculate. In this case, it is simply a multiplication of 12. From 10 to 120 is a simple multiplication of 12. So, you just multiply by 12. Or you can also use unitary method. For example, this will become, so if this 10 has become 120, this 19 will become 19 into 120 divided by 10. Similarly, this will become 5 into 120 divided by 10. Or this will become 6 into 120. And for that matter, all the other calculations you can do. I repeat, in the exam, you will get only one of these things to be calculated. So it is 6 into 120 by 10. And this one will be 8 into 120 by 10. So the total number of coins that the question is asking, it will be 19 into 12. So it is 228 coins total. If the question says number of coins of 1 rupee, so it will be 60 coins of 1 rupee. If the question is saying coins of 50 paisa, so it is 72 coins of 50 paisa. And this will be 96 coins of 25 paisa. So whichever you want to calculate, you can calculate like this. Right, so these are some of the examples, good examples of ratio. Okay. Okay, so now in this section, we will take some theoretical properties of ratios and combinations of ratios. So first, suppose if it is given that A is to B is 2 is to 3, then what will be the ratio of, alright, let's take them one by one. First of all, whenever, see, always you will get this kind of situation, right, wherein some unknowns and some knowns are combined in a ratio. Suppose we multiply by the same number, to the components of one side. We don't need to look at the other side. We don't need to do anything to the other side. Okay. For example, in the first question, we are multiplying by 5 to this A to this B. That means the other side will remain same. No change at all. Right? We have applied this actually in the question of milk and ages. We have already used this. Okay, we were multiplying the same numbers, so ratio wouldn't change. Right? But if you multiply by different numbers, then what will happen? Then we will have to look at the other side and do the same operation on the other side. For example, here the number corresponding to A is 2 and you are multiplying A by 6. So multiply this 2 by 6. So it becomes 12. Similarly, the number corresponding to B is 3 and you are multiplying B by 4. So multiply this 3 by 4. So it will become 12. Now what is 12 is to 12? You have to simplify this. The final answer will be 1 is to 1. Right? So understand that if you multiply by the same number, and similarly if you divide by the same number to all the components on one side of the ratio, the other side remains as it is. There will be no change on the other side. Alright, but if you multiply by the different number or you divide by the different number, then you have to multiply on the other side also. And then finally simplify it. Okay. Now A square is to B square. Following the same logic, in A you are multiplying by A, in B you are multiplying by B, that means different numbers. Okay, so the other side also will get affected. Or in simpler words, you can say A, we are squaring A, B, we are squaring B. So this 2 will become 4 and this 3 will become 9. So it becomes 2 square and 3 square. So the answer is 4 is to 9. Same goes with A cube is to B cube also. So we are taking cubes of both A and B. So we have to take cubes of both these 2 and 3. So it becomes 8 is to 27. Alright. What about this one? A square is to B cube. So 2 square 4 and 3 cube 27. No, it is wrong. Okay. Why is it wrong? See, as long as the power change was same in both the components or in all the components. Remember, power change has to be same. So here we were squaring, so the other also we will square. A we were taking cube, so B also we have to take cube. Here what we are doing is we are taking square of A but cube of B. That is not possible to be calculated. Okay, let's understand from the other perspective. If A is to B is 2 is to 3, we can very simply take A equal to 2x and B equal to 3x. Alright. Suppose we have to find, let's say A square is to B square. So A square is to B square will become 2x square is to 3x square. So 4x square is to 9x square. You see, we have taken same power. So x square will get cancelled and we get the answer as 4 is to 9. Whereas if the powers are different, let's say A square is to B cube, and you take these things, so 2x square is to 3x cube, so we get 4x square is to 27x cube. That means we get 4 is to 27x. Do we know x? No, we don't know. That means we cannot calculate these situations. What do we say? Cannot be determined for both these cases. So as long as the change in power is the same, you can calculate it, and in that case you don't even need to consider x. You can directly take these values as the values of A and B, because in the end also we are going to get ratio. So it doesn't matter what was the multiplying factor. But if the powers are different, then we need to know the actual values. So it cannot be calculated directly. If some other information is given, with the help of that we can calculate this. Just understand that. If the ratio is given, can you calculate this directly? No. If some other information, some additional information is given, then only we can calculate this. Alright? Okay. Now, similarly, once more, if I say if A is to B is 2 is to 3, what will be the ratio of 1 by A is to 1 by B? It is actually same as the power thing. Why? Because 1 by A is actually A to the power minus 1. 1 by B is B to the power minus 1. We are doing same power. So we do the same thing to the other side also. So 2 will become 1 by 2. 3 will become 1 by 3. Right? But remember, we never leave this in terms of fractions. So to remove fraction, what do we need to do? We take LCM of denominator. Now what is the LCM of denominator? 2 and 3, that is 6. Multiply by 6 on this side. To every component, multiply by 6. So it will become 1 by 2 into 6, 1 by 3 into 6. So that this becomes 3, this becomes 2. So the answer is 3 is to 2. So if A is to B is 2 is to 3, then 1 by A is to 1 by B will be 3 is to 2. Now some people can say, we could have directly written. Yes, we could have written, but only in case of 2 items. Right? In case of 2 values. If there are 3 values, then you cannot just reverse the order. Let's take an example. If we have A is to B is to C as 2 is to 3 is to 4, then what will be 1 by A is to 1 by B is to 1 by C? That will be 1 by 2 is to 1 by 3 is to 1 by 4. It will not be 4 is to 3 is to 2. Let's check it. Now here 2, 3, 4, LCM is 12, multiply by 12. You can do that calculation mentally. We'll get 1 by 2 into 12, that is 6. 1 by 3 into 12, that is 4. 1 by 4 into 12, that is 3. So the answer is 6 is to 4 is to 3. Be careful here. Alright? So if you are inverting each one of them, then only you can calculate, because then only all the powers will remain same. So for example, if I say, what is the, if A is to B is to C is given, if A is to B is to C is 2 is to 3 is to 4, then what is the value of 1 by A is to 1 by B is to 1 by C, is to C, let's say for example. So we say that it cannot be determined. Alright? So किसी एक का भी, even if we leave any one of them, we cannot calculate. Similarly here also, suppose we say A is to B is 2 is to 3, then what will be A is to 1 by B? We cannot say anything about this. Alright, be very careful here. Okay, let's take a couple of questions on this. Before that, we'll take some more properties, then we'll take some questions. Suppose we have one more type of property. If A is to B is 2 is to 3, what is the value of, let's say, find 6A plus 4B divided by 3A plus 6B, something like that. First of all, can we calculate? Following the logic of power, yes, we can calculate. I'll tell you simple, I've already explained, but here, this is one line thing that you have to remember. If the power of each of these terms is same, now power with respect to the variables or the unknowns, A and B. If the power is same, like here, power of A is 1, power of B is 1, power of A is 1, power of B is 1. So the power of each term is 1, hence we can calculate, right? And to calculate, one way is we can take A equal to 2x, B equal to 3x, put them here, x will get cancelled out and we get the answer. Or, once we know that the power is same, we don't need to consider x. Just put A equal to 2, B equal to 3. So this will become 6 into 2 plus 4 into 3 divided by 3 into 2 plus 6 into 3. So this becomes 6 into 12 and 12, 24 divided by 6 plus 18, 24. Oh, good. So this becomes 1 is to 1. So the answer is 1. But if suppose the question says find 3a square plus 4b square divided by 12ab, can we calculate this? Yes, we can still calculate, because the power of this term with respect to this unknown is 2. Power of this term with respect to the unknown is 2. But power of this term is still 2 because a into b. See, understand, a square is what? At the end of the day, it is a into a. So power 1, 1. And when you multiply, the powers get added. So 1 plus 1, 2. Even if it is a into b, the net power of the term will be 1 plus 1. That is 2 only. So we can calculate this. And if we know that we can calculate, then simply if we put the values of a as 2, b as 3. So this becomes 2 square, that is 4 into 3, 12. Now this is 3 square, 9 into 4, 36. divide by 12 into 2 into 3. So 12 2s are 24 into 3 72. So it is 48 by 72, which is 2:3. Oh, good. But there's only a coincidence that we get 2:3, yeah, right? So be careful. If we change the coefficient, we'll get a different answer. Okay. But in case, suppose we ask something like this, find 3a square plus 4b divided by 5b square plus 6a square. Can we calculate this? No, can't say. Why can't say? There is one term in which the power is different. Here the power is 2, here the power is 1, here the power is 2, here the power is 2. So we cannot calculate. Even if one term is different, right? Each and every term should have the same power. Even if one term has a different power, we cannot calculate. Right? Just be careful about it. Okay. The question can be asked in reverse also. So for example, 6a plus 4b upon 3a plus 6b is equal to 1, then find the ratio of a and b. So you can do the cross multiplication and calculate. We will take those examples in the session of exercise. Then the next thing can be combination of ratios. If a by b is equal to c by d is equal to 2 by 3, find 7a plus 6c divided by 7b plus 6d. First of all, can we calculate? Now see, yes, we can calculate as long as the coefficients of a and b are the same, coefficients of c and d are the same, and a and c are on the same side, b and d are on the same side. Then only we can calculate. If we make any change in this, we cannot calculate. Right? So this value can be calculated, and again, to calculate the value, we just put a equal to c equal to 2 and b equal to d equal to 3. I'll repeat. Say for example, I'll take another example. If the question was 3a plus 4c by 3b plus 5d, if it was, so here the coefficients of a and b are the same, a and c are on the same side, b and d are on the same side, but the coefficient of c and d are not same, so here we cannot calculate. Can't say. Right? This we can calculate by putting these values 2 and 3. So put them here. So 7 into 2, that is 14. 6 into 2, that is 12. Divide by 7 into 2, that is 14. And 6 into 3, that is 18. 7 to 3 is 21. So the final answer will be 28 upon 39. Is there any mistake that we have done? 7a plus 6, 7 into 2, 12, 40, 12, 26 upon 39. So it is 2 by 3. Now, did we actually need to do all this? No. As long as this condition is fulfilled, this ratio will remain same. Okay, so we don't even need to do this calculation. We simply say the value is the same. Okay, what does it mean? It means a by b is equal to c by d, then let's say we multiply a and b by k1, so k1a, k1b, we multiply c and d by k2, so k2c, k2d. As long as this continues like this, the ratio will remain same as the original ratios. Okay, this is how it is. Alright, so this is one very simple example, one very beautiful question actually. I'll give you a question on this. Question can be asked like this: if a by b is equal to c by d is equal to 4 by 5 and 3a plus 4c by 3b minus pd is equal to a finite number, find p. Right, so see, if this is a finite number, there is only one possibility, and that is coefficient of a and b should be same, coefficient of c and d should be same, and that finite number should be equal to this ratio only. So if it is given that it is a finite number, then there is only one possibility that coefficient of c should be equal to coefficient of d. So 4 should be equal to minus p, hence p should be equal to minus 4, hence that is the answer. So this is how the questions can be asked. That's it. इतना simple सा question हो सकता है इसके ऊपर. Suppose we have a is to b is 4 is to 5 and a is to c is 6 is to 5. What is a is to b is to c? How would you combine two ratios? 4 is to 5 is to 6? No, it is not 4 is to 5 is to 6. To combine, we need to identify the unknown number which is common to the ratios. Now here A is the common number. Look at the values corresponding to A. It is 4 here and 6 here. Make the values of A same in both the ratios. Right? Now LCM of 4 and 6 is 12. So to make it 12, if you want to make 4 12, we'll have to multiply this whole thing by 3. Right? So this will become 12 is to 15. Similarly, if you want to make the 6 12, we'll have to multiply by 2. But you can't multiply 6 alone. You'll have to multiply this whole thing by 2. So it becomes 12 is to 10. Right? Now A is to B is to C. So I'll just write below this. Corresponding to A, we have got number 12. In that case, when A is 12, B is 15 from here. So we write 15 in place of B. And corresponding to A 12, C should be 10. So this is the final ratio. 12 is to 15 is to 10. Be very careful here. I'll repeat. Identify the quantity which is common. Make the numbers corresponding to that quantity, the common quantity, equal by taking LCM and by multiplying. So you can see that different ratios are being multiplied by different numbers. Right? Let's take another one. If we have B is to C is 3 is to 4 and C is to A is 5 is to 8. So here C and C are common, and for the numbers, for C the numbers are 4 and 5, so make them equal. Now LCM of 4 and 5 is 20. So you want to make this to 20, it will become, I'll write above this, so 4 5s are is 20, so 3 5s are 15. So I'll remove this. Then similarly, if you want to make this 5 equal to 20 multiplied by 4, so 8 multiplied by 4, 32. So remove this. So the final answer A is to B is to C will be equal to, write the common number first, C ke liye, the value that we have got is 20. Now when C is 20, B has to be 15. And when C is 20, A has to be 32. So the final answer is 32 is to 15 is to 20. Alright. Now in both these questions, suppose here A is to B was given, A is to C was given. So what would be B is to C? So B is to C, you can calculate it in two ways. One, you can find the combined ratio, and then from here you can calculate B is to C. Just simply remove it, simply take them out. That is 15 is to 10. But you can't leave 15 is to 10 like this because it will get simplified and this will become 3 is to 2. Right? This is one way. And the other way is multiply or divide these two in such a manner that A gets cancelled out. Because here we have A by B is equal to 12 by 15, 4 by 5. And A by C is 6 by 5. So simply divide. So if you divide A by B by A by C, A will get cancelled out. 4 by 5 by 6 by 5. Alright. So this 5 and 5 get cancelled, A and A get cancelled. So we get C by B is equal to 4 by 6, which is 2 by 3. So B is to C will be, so B by C will be 3 by 2. So whichever way you are comfortable with, you can calculate. I'll repeat. First method to calculate B is to C will be combine these two to get one single ratio and from there take B is to C. Okay. Or using these two ratios, either you multiply them or you divide them, making sure the non-required unknown goes out. So here we need only B and C, so we have to eliminate A. So you just divide. Similarly in this one, B is to C is given, C is to A is given. Which one is not given? A is to B. Okay, so if you want to calculate A is to B, write this as B by C equal to 3 by 4 and C by A was 5 by 8. Just by looking at them, if you want to eliminate C, what you will have to do? In this case, you divide it. Here you need to multiply. So B by C into C by A. That will become 3 by 4 into 5 by 8. So I'll just remember, the one that you do not need, eliminate it. So in this case, we wanted to find, the question was find A is to B. Okay. So remove C. And in this case, C can be removed by multiplication. So C gets cancelled and we get B by A equal to 15 divided by 32. Or A by B is 32 by 15. So the answer is 32 is to 15. This is one way. Or the other way is find the combined ratio and from there you can take out 32 is to 15. So this is how you can combine the ratio or you can separate from a combination of ratio. The ratio of surface areas of a cuboid is 3 is to 4 is to 5. volume is 216,000 meter cube. Find ratio of sides or the edges. Now, what is a cuboid? We all know that cuboid is a 3D, 3-dimension figure like this. So we have L, B and H. When you say surface area, there are 6 surfaces. But when you calculate the surface area values, there will be 3 values. Let's say, for example, this top area, this is L, this is B. So the top area will be L into B. This side area will be B into H. And this front area will be L into H. Now the bottom area will also be L into B. The back area, which we can't see, is also L into H. And the surface parallel to this surface on the back of this will also be B into H. So there will be 6 surfaces, but the value of surface areas will be only 3. And the values are L into B, L into H and B into H. Alright, just check them. So the question is find the ratio of sides. So what we have to find is L is to B is to H. The order is not important, so don't worry about it. You can just write them in increasing order, decreasing order. Now what to do? Now there are many ways to do this, but yeah, actually this is a diversion, okay, to make you fool, right? So don't fall for it. We will just use this combination thing or separation thing rather. What is given? It says ratio of surface areas. That means ratio of LB is to LH is to BH. That is given 3:4:5. Alright. From here we have to find L is to B is to H. Just separate them. For example, if you take 2 of them, so LB is to LH. That is 3:4. From here L gets cancelled out and we get B is to H equal to 3:4. Alright. Similarly, if you take these two, what will happen? LH is to BH. That is 4:5. H gets cancelled out, we get L is to B equal to 4:5. Wow. So now we have these two ratios, combine them. Which one is the common quantity? B. What are the numbers for B? 3 and 5. Now LCM of 3 and 5 is 15. So make this 15, this will become 20. Make this 15, 5 3s are 15, so 4 3s are 12. So L is to B is to H will be, now see, which one is common? B, and for B we have taken 15. Now when B is 15, H has to be 20. And when B is 15, L has to be 12. So the answer is 12 is to 15 is to 20. Or 20 is to 15 is to 12. Don't worry. Option में there will be only one of them. So this is one way of doing it. Volume was just camouflage, which you should avoid in this case. Not necessary. See, understand, we are not asking the values of length, breadth and height. We just want the ratio of length, breadth and height. Okay? Now, from here only, there is one more way of doing this. I'll write this again. LB is to LH is to BH. Is 3:4:5? Now, we have just done a property that if we multiply or divide by the same number to all the components on one side, there is no change on the other side. Okay? So, divide each one of these 3 numbers by LBH. Again, you don't need to use the value of LBH. Volume is LBH, that is given. You don't need to use the value, just LBH expression. The other side will remain 3:4:5. Now here you see, LB by LBH will become 1 by H. LH by LBH will become 1 by B. And BH by LBH will become 1 by L. And that is 3:4:5. From here, what we need to do is just invert this. So if you invert this, and we are inverting each one of them, so it becomes H is to B is to L. The other side will get inverted, will become 1 by 3 is to 1 by 4 is to 1 by 5. You don't leave it like this. You simplify. So LCM of denominator 3, 4 and 5, that is 60. Multiply by 16 each one of them. So you get H is to B is to L as 16 to 1 by 3, 20. 16 to 1 by 4, 15. 16 to 1 by 5 is 12. Or if you want to write in this order, just take the options. In the option you will have only numbers, right? So it doesn't matter whether it is L first or H first. Okay, so this is how you need to do these questions. Alright. It's a question of actually division. It just came to my mind. Rupees 75,000 are divided among A, B and C such that A gets half of amounts of B and C together. B and C together. Okay. B gets 1/4 of amounts of A and C together. Find their individual shares. Individual shares. Just consider the amount of A as A, amount of B as B, amount of C as C. So the first equation that we get is A plus B plus C is equal to 75,000. Now second equation, A gets half of the amounts of B and C together. So whatever B and C get, half of that is equal to A. So instead of making an equation, just do one thing. Bring 2 on this side. So 2A is equal to B plus C. Now in this equation, in place of B plus C, write 2A. So it will become A plus 2A, right? And that is 75,000. So 3A is 75,000. So A's share is 25,000 rupees. So very simply we can find A. Alright. Then second, B gets 1/4 of the amounts of A and C together. Alright, so I'll write this as B equal to A plus C by 4. And we still have A plus B plus C equal to 75,000. Now from here we get 4B is equal to A plus C. Right? Now see, in place of A plus C, write 4B. So we will get A plus C will become 4B. So 4B plus B, that is equal to 75,000. So we have 5B equal to 75,000. Right? So B is equal to 15,000 rupees. Now we have got A and B, so automatically C you can get by subtracting these values from 75,000. Now 15,000 plus 25,000, that is 40,000. So it is 35,000, the remaining 35,000. You can also find the ratio of ABC, and that will be equal to 25,000 is to 15,000 is to 35,000. That will become, I'll write this as 25,000 is to 15,000 is to 35,000. Now zeros will get cancelled, and 5, it will also get cancelled by 5. So 5 is to 3 is to 7. This would be the required ratio. So these are some good basic questions related to ratios and their properties. Right now we'll just try and see these statements. When we say 3 numbers, if 3 numbers A, B, C are in proportion, alright. So if you know geometric progression, don't use it much here. When you simply say that 3 numbers A, B, C are in proportion, it means A by B is equal to B by C. As simple as that. Right? Here the number in the middle, that B, the number in the middle will always appear twice, and the number that appears twice is called mean proportion. So B is mean proportion. It is the name of that quantity, so don't worry much. Mean proportion of A and C. Right? So the middle number or the number which is there in between will be called mean proportion of the numbers at the end. Similarly, this C is third proportion. Now, so when I say third proportion, it will mean third proportion to A and B. Obviously, if you wish, you can say that this A is first proportion to B and C. Okay. Now, how can the questions be asked? I'll write one question here. Find mean proportion of 16 and 36. Very simple. Right? So what will you do? You write 16 first, you write 36 in the end, and you write x in the end, assuming x is the mean proportion. Remember, mean proportion is the number in between. So we have to say that 16, x and 36 are in proportion. So once we get this, we can write this relation 16 upon x is equal to x upon 36. Understand once more. When I say find mean proportion of 16 and 36, so we write 16 and 36 in the end, we insert number x in between, and we say that they are in proportion. And if they are in proportion, then we can apply the same rule. A upon B is going to be upon C. In place of A, 16 would come. In place of B, x would come. In place of C, 36 would come. And then you simplify. So we get x into x, 16 into 36. So 16 into 36 is equal to x squared. As you know, 16 is 4 squared, 36 is 6 squared. So x will be equal to 4 into 6, which is 24. So 24 is the mean proportion of 16 and 36. Alright. But at the same time, if I say find third proportion to 16 and 36. Now how do you interpret this? Remember, third proportion should come in the end. So what do we say? 16, 36 and then y. Then this y would represent the third proportion. And we write this as 16 upon 36 equal to 36 upon y. And if you simplify, you'll get the values of y, or value of y. Right? So I think this is, from here, y is equal to 36 into 36 divided by 16. So 4 times, 4 9 times, and 4 9 times. So we get y is equal to 81. This is the answer. So try and understand that 24 is the mean proportion of 16 and 36. 81 is third proportion to 16 and 36. Right? So one number we calculated here which was in between 16 and 36. And here one number we are calculating which is after 36. And this we followed this proportionality rule. And suppose in case we are asked to find the first proportion, I'll put a small question like this. Find first proportion to 16 and 36. How do we go about it? We say A 16, 36. They are in proportion. So we say A upon 16 is equal to 16 upon 36. Right? So from here we get A is equal to 16 into 16 by 36. So if there is any cancellation possible, do it. So it is 64 by 9. So A's value is 64 by 9. If at all, this is the question. So please understand that all these three questions are different. Right? Even though the numbers are same, or you can see that all these questions are absolutely different. So this is for three numbers in proportion. So whenever, so in the book or in the exercise, you will have a couple of more questions on this. You just follow this property, this rule. If this is the statement, A, B, C are in proportion, then this is the ratio that has to be done. And suppose if this statement is not given, question is simply saying that this is, or find the mean proportion, or find the third proportion, or find the first proportion. You make such an order, and then accordingly you apply the ratio. What if there are four numbers? So in our questions of this chapter, particularly only for this chapter, the language of the question would be, suppose in case we get four numbers, A, B, C, D are in proportion. Right? See, here what we mean to say, we do not mean to say continued proportion. See, understand the difference. If it was continued proportion, okay, if it was continued proportion, the relation would be A upon B equal to B upon C equal to C upon D, right? So if the situation was of continued proportion, it would be A by B, B by C, C by D. Now this is same as geometric progression. Here right now we are not working on progression. We will do that separately. Okay. So specifically for this situation, if we simply say four numbers are in proportion, then we will not consider the continuity. Okay. We will just take A by B equal to C by D. So I will clarify once more. In this chapter, when the questions are for four numbers in proportion, then this is the relation that has to be used. A by B is equal to C by D. Okay. But if it is for continued proportion, even in this chapter, if they use this word, then you use this B by C also. In most of the questions, in our situation, all the questions would have this relation only. Okay. For example, if the question says, what must be added to each of 33, 45, 69, 93 to make them in proportion, so that they come in a proportion. What will you do? Understand the question? What must be added to each of these? So if I suppose I say that x is the number to be added, then how do I write the relation? 33 plus x divide by 45 plus x, because they are going to become a proportion, right? Now this one 69 plus x and the last one 93 plus x. Question is, what must be added to make them in proportion? So add x to each one of them. So we get 33 plus x, 45 plus x, 69 plus x, 93 plus x. We will not use the continued proportion thing. We will use this one. Okay. Now if you simplify, you will get the answer. Now you don't need to simplify. I'll give in these questions, use the options given. Suppose the options are -1, 2, 3, 7. Use the options. If you put x equal to -1, this will become 33 minus 1, that is 32. 45 minus 1, 44. And this side will become 69 minus 1, 68, and 93 minus 1, 92. Are these two ratios same? No. You can check this. This is 4, 8 divided by 11. This is not a multiple of 11, this is not a multiple of 8. So simply it is wrong. Okay. So this -1 is wrong. If you take 2, if you put 2, this will become 35. This will become 47. Here if you put 2, it will become 71. And this will become 95. Very clearly, this 95 is not divisible by 47. 47 is a prime number. So this also is wrong. If you put x equal to 3, what will happen? This will become 36. And this 45 plus 3 will become 48. This is equal to 69 plus 3, that is 72. And 93 plus 3, that is 96. Now check. This is 12 3s are, 12 4s are. This is 24 3s are. This is 24 4s are. Right. So they are equal. So this is the correct situation. You don't need to check 7. So the answer is 3. Trust me, you'll never have to you'll never be required to do some calculations here. Alright. So CLAT question. What fraction bears the same ratio to 3 by 5 as 2 by 7 bears with 1 by 2. So what fraction bears the same ratio to 3 by 5? So suppose that fraction is x, then x is to 3 by 5 is equal to 2 by 7 is to 1 by 2. This is what the question says. Right? So this can be written as x divided by 3 by 5 is equal to 2 by 7 divided by 1 by 2. So be careful about the order. It says what fraction bears the same ratio to 3 by 5. So x will come at the first position, then 3 by 5, and then 2 by 7 bears to 1 by 2. Let's simplify. So you will get 5x by 3 equal to 4 by 7. So finally from here we get x is equal to 12 by 35. So the required fraction is 12 by 35.